Hi, my name is Michelle Nazareth, and I'm currently a junior in high school. Thank you for reviewing my project for Sigma Xi. My project last year was RNA regulation, identifying and preventing AMP depurination in early life RNA polymerization. My project was about the origins of life on the Earth 4 billion years ago. There was not much on the Earth. There was oceans, there were volcanoes, and there was carbon, oxygen, phosphorus, just the simple elements, but nothing else. So how did life begin then? How did life go from RNA or DNA to protocells into life we know today? Well, the RNA world hypothesis is that actually life started with RNA and not DNA as its genetic component. But still the question remains, if RNA was there but there were no enzymes, how did it polymerize and how did it become longer chains from monomers and actually form cells? It turns out that on the volcanoes there are little pools in the hydrothermic pools, and under there the RNA went through wet-dry cycling. So the wet-dry cycling is basically when it rains down, the RNA gets in the water and hydrolyzed, and then it dries down and goes through that process over and over again, and in that process the RNA can actually polymerize. But the biggest problem with this theory is that in that happen, AMP depurinates, meaning it breaks at the N-glycoside bond. And that's bad because if AMP depurinates, then there's no way you can form your RNA polymer. That's what I investigated in my project on AMP depurination. I set out to first of all replicate it in the lab and then inhibit it using LPC, which is a lipid, and adenine. After my experiment, I figured out that two things. One, that LPC actually inhibits depurination, and so does adenine. But I did some statistical testing to see how much was actually inhibited, and it turns out that after 60 and 90 minutes, adenine statistically significantly reduces the amount of depurination that's present in the samples. And that's really important. My work is really important because it provides a solution to problems in the field of AMP depurination. It provides a solution that could have been plausible on the Earth 4 billion years ago too. Like for example, we know that if AMP was present on the Earth, then adenine had to be present because adenine is just a part of AMP. And even if LPC, lysophosphatidyl-choline, wasn't present on the Earth, we know that there are similar lipid compounds like decanoic acid that could have exhibited similar effects that protected the AMP from depurination in the harsh volcanic conditions. I was influenced a lot in my work by other professionals in the field, like my mentor, Dr. David Deemer, and other researchers like Dr. Bruce Damer. I think their research is really fascinating, and there's still research coming out to this day. Like, for example, just in this past October, Dr. Becker's work on polymerizing all kinds of nucleic acids in the similar wet-dry conditions that I did in my experiment just really fascinating. It's not every day that we get to talk about the origins of life, and I think we should. There's no way we could ever know what happened and how life originally formed on the Earth 4 billion years ago. But by working on these theories and filling in all the small holes and with experimentation and really solidifying the theories, we can come close to guessing at what happened. And also by knowing that, we can guess how life formed today and even up to this day, and maybe even how life can synthesize on other planets too. Thank you for reading about my project. If you have any questions, please leave a comment on my website, and I'll be sure to get back as soon as possible. Thank you.